Alright, so in this video, we're going to be talking about how to differentiate trigonometric functions. Example like this one right here. If y is equal to sine squared x, what is dy dx? Now, before we start solving problems, there are some key things that I want you to understand. If you are given the 6 main trig ratios, what are their derivatives? So let's start. Now, let's just say we have sine x, which always goes with cos x, and then we also have tangent x, which goes with secant x. Then we have cotangent x, which goes with cosecant x. Now, if you are given any of these trig ratios, how do we find their derivatives? In other words, how do we differentiate? Now, it turns out that for sine and cosine, it is pretty easy because we can use the Cartesian plane to determine that. So, what is the differential of sine x? If we differentiate sine x, we're going to be getting positive cos x. However, if we differentiate cos x, we're going to be getting negative sine x. Now, we can use the Cartesian plane, just as I said, to remember this all the time. So, if you are familiar with trigs, you notice that the y-axis is always sine x, and then the x-axis is cos x. Then if this side right here is sine x, then here is going to be negative sine x, and then this side will be negative cos x. So let me put it down real quick. Negative cos x. Cool. Now, if we stand on sine x and then move in clockwise direction, we are doing differentiation. All right. Then if we stand on sine x and then move in anti-clockwise direction, we are doing antiderivative, which is also known as integration. All right, so these are some of the key things that you need to understand. So the fastest way is going to be something like this. You put down this plus sign like that, and then you put here x, which stands for sine. You put here c, which is for cos. Here will be negative sine, and then here will be negative cos. So assuming you are given y is equal to negative sine, and you are asked to differentiate. So all you have to do is to stand on this negative sine, and then you move in clockwise direction till you get to the next trig ratio, and you realize that we are landing on negative cos. Again, let's just say we are given y is equal to negative cos x, and then we are asked to differentiate it. So we have to stand on negative cos and then move till we get to the next trig ratio, but always remember that we are moving in clockwise direction. So you see that we are landing on sine, so that means the differential of negative cos is giving us positive sine of the angle given in the question. As simple as that. So that is pretty easy in my own opinion. But how about tangent x and then secant x? So these two also move together, but there is no realistic trick to this one. All you have to remember is that if you differentiate tan x, you're going to be getting this right here, but squared of that. So it's going to be secant squared x. Then if you differentiate secant x, you're going to be getting itself and then this right here. So it's going to be secant x, this time no squared, then times tan x. Now, how about cotangent x and then cosecant x? Just as we have right here, they also move together. But one thing you need to understand is that once they are starting with c, their answers are going to be getting negative signs, right? So that means if we differentiate this one, first things first, we are going to be getting negative, so we have to put negative down there. So you realize that this one also starts with c, and we are getting negative right here. So that is one key thing that you have to also keep in mind. So when we differentiate cotangent x, we're going to be getting this right here, but just that it's going to be squared, just as we had over here. So this is also going to give us cosecant squared x. Then if we differentiate cosecant x, we're going to be getting itself and then this right here. So this is super easy to remember. It's going to be cosecant x cotangent x, and you are 100% done. So that is it, and these are the 6 main trig ratios that I want you to keep in mind. Now, let's keep going. How do we solve this problem right here? Now, before we start, understand that this is how trig ratios accept powers. So if you want to differentiate a function with a power, all you have to do is to rewrite it in a way that will be pretty easy to differentiate. So instead of keeping it this way, I'm going to have to write it as y is equal to sine x all to the power 2, and they are the same. Now, when you have a situation like this, there are two ways. You can just do it straight away or by using the substitution method. So if you want to do it straight away, then precisely we have to move this power to the front right here. So that is going to be dy dx is equal to, which means we are differentiating, obviously. We move the 2 to the front, then we keep everything inside the parentheses. So sine x, then we subtract 1 from the power, and we are going to be getting 1 right here. Now, because the power is 1, we don't need to write. Then from there, we have to also go ahead and then differentiate the inside. And the differential of sine x, just as we discussed, is going to be cos x, which is positive. And one key thing you need to know here is that the differential of the inside will always multiply what you've gotten. That is how come I've put in dot right there, right? Meaning they are multiplying. So to clean this up, we're going to be getting 2 cos x sine x. And that is pretty much it for this question. How do we differentiate problems like this? So just as we have discussed before, we have to rewrite it in a way that we can easily differentiate. So this is going to be sine x squared plus 1, then all raised to the 7th power. That is the implication. Now let's go ahead and then differentiate this straight away. Then after that, I'll show you the substitution method. So over here, dy dx is going to be equal to, again, we take this power right here, then we move it all the way to the front. So we're going to be getting 7, then we have sine x squared plus 1, then just as we know, we subtract 1 from the power over here, and it's going to be equal to 6. So this is what we have. And you notice that the inside is also differentiable, and when we are differentiating, we consider the trig function over here. All right, so the differential of sine is going to be cos, and remember, we are going to be multiplying, so it's going to be cos of this angle right here, which is x squared plus 1. And you notice that the angle is also differentiable. We can go ahead and then differentiate the angle right here. The differential of x squared plus 1 is just giving us 2x, because when we differentiate any constant, we are getting 0. So that is something that you have to also keep in mind. Now, this is what we have. Now, don't make this mistake by multiplying what we have here by the function inside the parentheses, because it's locked with this power right here. So we can't just do that, right? So what we are going to do is that we're going to be taking this 7 and then multiply by that. And 7 times 2x is going to be positive 14x. I will choose to write this right here before this, right? So it's going to be 14x times cos x squared plus 1. Then we have this right here. Then this is going to be sine x squared plus 1 all to the 6th power. But remember, trig ratios do not accept powers this way. So I'm going to have to put the 6 right here instead. And that is pretty much it for this question, chat. That is it. So dy dx is equal to this right here. Now, how about if you want to use substitution for this? It turns out that that is also super easy. If you want to use substitution for this one, the method is literally the same, but just that you're going to be doing a lot of differentiation. But keep in mind that still we have to rewrite it this way, okay? So what we are going to do is that we are going to let the function inside the parentheses be equal to u. So that means u is equal to sine x squared plus 1. That means the new function is going to be y is equal to u to the 7th power. Then we go ahead and then differentiate y with respect to u. And if we do that, we're going to be getting dy du is equal to 7u. Then we subtract 1 from this power, and we're going to be getting 6. Now, if we want to differentiate u with respect to x, then this is going to be the differential of sine is giving us cos, so we're going to be getting cos of the angle right here, which is x squared plus 1. Then the angle is also differentiable, and that will give us 2x. And we can simplify this one to 2x cos x squared plus 1. Now we have our du dx. Now remember, our interest is in dy dx. So how do we get dy dx? Now we can use chain rule for this, and anytime you are writing a chain rule and then you are writing with dy dx, you end up getting two fractions multiplying each other, and the numerator of the fraction will be this right here, so which is dy. Then the denominator of the second fraction is going to be this right here, which is dx. Now we are left with knowing this side and then this side. Now what are we going to put right here? Now you notice that we have u in the function, we have this right here du dx, we have dy du. So it is advisable to put du right here, so that in case they cancel out, we are still getting our dy dx back. As simple as that. Now you realize that we know what this is right from here. Dy du, we had it to be 7u to the 6th power. So that means we can go ahead and then find dy dx so easily. So dy dx is going to be equal to the whole of this, which is 7u to the 6th power, then times du dx, which is giving us the whole of this. So that means we're going to be getting 2x cos x squared plus 1, like that. Then we simplify this further. Again, we can just take this right here and then multiply by this, right? So 7 times 2 is giving us 14. So we're going to be getting dy dx is equal to 14. Then there is this x right here, so I'm going to have to put it down. Then we have this, I'll choose to write this first, which is cos x squared plus 1, then followed by u to the 6th power. So u to the 6th power. However, we allowed sine x squared plus 1 be equal to u, so we have to go back and then replace that with the u. So replace the u with that. So we're gonna be getting dy dx is equal to 14x cos x squared plus 1. Then we have the next one to be sine x squared plus 1 all raised to the 6th power. All right, so I'm gonna have to write it this way, to the 6th power. But just as we discussed, sine or trig ratios do not accept powers this way, so we have to move this power all the way to the front right here so that it will look nicer, and that is the way that they accept powers. So I'm gonna have to put the 6 right here, and that is pretty much it for this question. Now what if we are given y is equal to 3 times tan x to the 4th power? So let's just say we are given something like this. Again, how do we differentiate? So still, what we're gonna do is that we're gonna write the function as 3 times tan x to the 4th power, and you can just do it straightforward. So if you want to do it straightforward, then that means we're gonna be getting dy dx is equal to, we take this 4 right here, then we move it to the front to multiply the 3, and that is going to be 3 times 4, which is giving us 12. Then we put everything here, we keep everything, so we're gonna be getting tan x, then we subtract 1 from the power, and we are going to have the power to be 3. However, inside the parentheses there is a differentiable function, which is tan x. So what is the differential of tan x? So tan always goes with secant x, so the differential of tan x is going to be secant squared x, and that is pretty much it. Then we go ahead and then simplify this further, because trig ratios do not accept powers this way. So that means we're going to be getting dy dx is equal to 12, then I'll write this one after that, which is secant squared x, then we have tan x all raised to the 3rd power, but I'm not gonna do that because it accepts powers this way. And that is it for this problem. It is also easy. So how about this right here? Feel free to pause the video and give it a try first. So here we're gonna be getting dy dx is equal to, what is the differential of cos? So if we differentiate cosine, we're going to be getting negative sine. Then the angle right here is giving us x squared minus x. All right, then you notice that inside the parentheses there is a differentiable function, so we have to go ahead and then differentiate this. But like we said earlier, once we differentiate that, it's going to be multiplying what we have. 2x, then the differential of x is giving us just 1, and this is what we are getting, and we can choose to bring this one to the front, and if we do that, we're going to be getting our answer to be negative, then 2x minus 1 sine x squared minus x. And that is pretty it for this question. Now what if we have, so anytime you have a situation like this, we have to go ahead and then use the product rule, because this is a function, this is also a function, and they are multiplying. So to use the product rule, it is pretty easy. You keep the first differentiable function, then you differentiate the other. So let me write it right here. If you have y is equal to, let's say, uv, where u is a function and v is a function, if we want to differentiate this one using the product rule, then obviously we're going to be getting dy dx is equal to, you keep the u, you differentiate the v, then plus you keep the v, you differentiate the u, as simple as that, right? So this is pretty much what we're going to be using. So let's keep going. Now right here, what I'm going to do is that I'm just going to keep this first function. So I'm going to keep this right here, x to the 4, and then differentiate the cos x. So that means I'll keep this right here, x to the 4, then the differential of this right here is going to be negative sine. So if we differentiate cos, we are getting negative sine x. Let me k this and then d that. That means I'm keeping this one, so cos x, then I'm going to have to differentiate this right here, and it's going to give me 4x to the third. Now, to avoid confusion, I just have to move this one to the front. And if I do that, there is minus right here. I'm going to have to write that first. So we have minus, then x to the 4th, multiplying sine x. Then I'm going to have to also write this one before the trig ratio. So plus 4x cubed, then cos x. So this is what we have, but to make this one look more nicer, I'm gonna have to write this one. So this will be 4x cubed cos x, then minus x to the 4th sine x. And that is it for this problem. All right, now how about this question right here? If you are given y is equal to x squared over sine x, how do we differentiate? So feel free to pause the video and give it a try. Now, anytime you have a fraction like this one, I'll always advise you to go for the quotient rule. And this is how the quotient rule works. If we have a function, then the differential of that function is going to be v u prime minus u v prime, all divided by v squared. So one key thing you need to know here is that you have to always set the denominator to v and then the numerator to u. So that means after setting each one of them to the variables, then we go ahead, we keep one, we differentiate, but always we keep this one first, then we differentiate the numerator side, then minus, we keep the numerator, we differentiate the denominator. Once we are done, then we keep the denominator, then we square it, right? So let's keep going. Now what I'm going to do is that I'm just going to let u be equal to x squared, and then we have v to be equal to sine x. So these are the two equations. Now because we will be needing u prime, it means that we have to differentiate this. So when we differentiate u, we are going to be getting 2x. So let me go ahead and then use the red marker. We're going to be getting 2x, and then when we differentiate v, we're going to be getting cos x. So we know everything in this formula. We can just go ahead and then do substitution. So therefore we're going to be getting the function to be y prime to be equal to v, where v is sine x. So we have sine x right here multiplying u prime, which is 2x, so times 2x, then minus u, which is giving us x squared, multiplying v prime, which is cos x, all divided by v squared, where v is sine x, so we're going to be getting sine x squared. Then from here we go ahead and then clean this up. So what I'm going to do is that I'm going to rewrite this one in the front because it's as if this is serving as an angle. However, it's not an angle. So this will be y prime is equal to 2x sine x, then minus x squared cos x, all divided by sine squared x. I've told you that trig ratios do not accept power this way. This is how it's gonna be. And from here, you can just go ahead and then factor out x. I think that is the only thing that we can do from here. So maybe y prime is gonna be x out, then we have 2 sine x minus x cos x, all divided by sine squared x. And that is it for this problem. Y is equal to secant square root of x all to the power 2, and then we are going to let u be equal to secant square root of x. So that means the original function is going to be y is equal to u squared. Then we differentiate y with respect to u. So dy du will give us 2u. Then we have to also go ahead and then differentiate this u with respect to x. So right here, I just want to use the yellow marker for that. So du dx is equal to the differential of secant is going to be secant of the angle, which is square root of x, then times tangent of the same angle. So I'm going to have to put it down like that. Then from here, we have to also differentiate the angle. So the angle right there is also, now square root of x is also the same as, so let me put dx of x to the power 1/2. All right, so positive 1/2. So that means this is going to give us secant square root of x tangent square root of x, then times, now we are differentiating, okay, so we have to move this half to the front. So that is going to be 1/2 x to the power, then we subtract 1 from the power, which is giving us negative 1/2. So it turns out that this right here is going to be secant square root of x tangent square root of x times 1/2 times x to the power 1/2. But take note, x to the power 1/2 is the same as square root of x. So instead of writing it this way, I'm gonna have to write it as 2 times square root of x. So now we know everything. We can go back to the function and then put it right there. Remember, we are interested in dy dx and we are using substitution. Therefore, we're going to be writing this as dy over something multiplying something over dx. And we notice that we have functions in the form of u, so that means we have to put du right here and then du right there, right? Now we know what dy du is. It is over here, which is 2u. So what I'm going to do is that I'm just going to put 2u for this right here. Then we have du dx, which is also giving us the whole of that, right? So we are going to have this, so times secant square root of x tangent square root of x, all divided by square root of 2. So square root of, did I say square root of 2? 2 square root of x rather. So this is what we have, right? And you notice that as it stands now, these two values can cancel out. This and this can cancel out since we are multiplying, right? And then we are going to be getting, you notice that we have u in the function, but actually we allowed u to be equal to secant square root of x. So instead of writing u, I'm gonna have to put secant square root of x, which is technically the u that we said right here. Then we also have another one, secant square root of x, and then this is also multiplying tangent square root of x, all divided by square root of x. Now we can go ahead and then simplify this further, because secant is multiplying secant, so we can have secant squared. So we're going to be getting dy dx is equal to secant square root of x tangent square root of x, all divided by square root of x. And that is pretty much it for this.